Assalamualaikum. My name is Muhammad Nur Farhan bin Muhammad Zaki. My group was made an experiment about mass spring system. For introduction of this experiment, vibration is a periodic motion of the particle of an elastic body after force applied to the system. It will repeat itself in period of time. Vibration can be divided into two categories, which is free vibration and forced vibration. The mass spring system is a free vibration system. Free vibration are oscillation where the total energy stays the same over the time. For this experiment, the weight is pulled down and released. The system will respond to vibrating vertically. The system is free vibration. Free vibration is divided into two types, which is undamped vibration and damped vibration. This experiment is undamped vibration because there is no resistance or damping in a system. Vibration system has three types, which is single degree of freedom, 2 degree of freedom, and multi-degree of freedom. For the mass spring system, the experiment is a single degree of freedom. The objective for our experiment is to determine the stiffness of the spring, to determine the natural frequency of single degree of freedom in free vibration system, and to determine the decay rate in free vibration system. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. For my part, I'm doing for setup and apparatus. Okay, for the basic apparatus, as we can see here, this is originally set up by instructor. We have a sensor. This sensor measure the displacement. Okay, that given by load. We need the laptop, national instrument, ruler, and the ZLED. Okay. For the load, we use 0.5, 1.1, 1.5, and 2.0 kilogram. Okay. For the needle is need to provide basic DAQ functionality for application such as simple data logging and portable measurement. Okay, we also use needle for faster sampling, more accurate measurement, and calibration support. Okay, for the ZLab, we used to design individual measurement and analysis application.
Assalamualaikum warahmatullahi wabarakatuh. I'm going to explain how to take the displacement for this spring mesh system. At first, we have to measure the length from here to here, and then we set it as 0. And then we take load here about 0.5 kilogram, and then we put at the load holder here. And then we take the value from here to here, and then we substitute the value with the length when at 0. And then we repeat the step. We put another load here, so it will be 1 kilogram. Do the same step like before, and then take another one. And another one. There is 2 kilogram here. So that's how we calculate the displacement. And here is the value after we take the displacement. For 0, we get 0. 5 Newton, 1.8 centimeter, and for 10 kilogram, 4.2 centimeter, 15 Newton, 7 centimeter, 20 Newton, 9.5 centimeter.
Assalamualaikum. My name is Muhammad Ani Ramli. I'm going to show you how we do the Desilet.
Now that we finished already the overall module, let me explain each of the function for every module here. First, the problem is the data transmitted from the hardware into the software is in voltage value, so we need to change it into displacement. So for doing that, we need to use scaling. By using scaling, we will enter the function of graph here between displacement and velocity. So first we need to draw the graph between displacement and velocity by using data we calculated manually. So now that we are going to plot the graph between displacement and voltage, we need the voltage value from Desilet and displacement from manual measurement when certain load is applied to the spring system. We already got the values. We use the graph software and we just need to enter the value here, 0, okay, and just okay, and we got the graph. So we just need to plot the linear one, and we already got the equation of graph here, and we just need to put the value here in the Desilet. The next data output from scaling is in displacement value. The thing that we can see from the YT chart is something like this, which it is the displacement over time data when we oscillate the system. We can see here the graph is a little bit rough. To overcome that, we need to use digital filter. Then the graph will become smooth. Now we are finished about the displacement, so we need to save the data in the Microsoft Excel. Next, we are going to find the velocity from the displacement data we got before. So we use the derivative here and we use differentiate, because from displacement we need to differentiate the equation so that we can get the velocity. And now we are going to proceed for acceleration, because we are going to use acceleration to get the FFT value. From the acceleration we are going to find the FFT. So we just use the FFT module. The pattern of the graph maybe something like this. Then we can get the value at here. So the FFT is plus minus 320 Hertz.
Okay. From the graph before that, we get the value of K, that is 2.0550272. Okay. From this value of K, we just substitute the value of K into the formula here, into the formula of natural frequency, that is W0. Okay. From that we get all of this constant, that is 0.641, 0.453, 0.370 and 0.320. Okay, that's all from me. Okay, here I will show you how to plot a graph and how to find the value of K. Okay, the first thing is we need to put the data, the value of the force and the displacement from the data that we already collect in the experiment. Okay, the value of X is actually the value of displacement, and the y here is represent to the value of force or mass. Okay, we just click OK, and here we get the point. Okay, then we get the graph here, the linear graph. Okay, this is the function of graph. Okay, fx equals to 2.0550272x plus 0.7537772. Okay, this value is actually the value of gradient. Okay, the value of gradient is actually the value of k. Okay, after this I will show you how to find the value of natural frequency. Thank you.